video will show you how to make a laser tripwire using the Arduino, a laser module. My laser module looks like this. It's not incredibly powerful, I've got it turned on at the moment, but I wouldn't look into it. Also you'll need a photoresistor, otherwise known as a photo cell, an LED, a buzzer, although then you could do with either of them, you don't necessarily need both, and a few resistors. You'll need two 220 ohm resistors, which look like this. Can't get the camera to focus in very well. And as well as them two 220 ohm resistors, you'll need a kilo ohm resistor. But again, I'm struggling to get the camera to focus. I'm going to show you how I've done the wiring now, and then I'll go into more detail about how photocells work, and then I'll explain the code I've written for this. But the code you might need to change depending on how powerful the laser is, at what distance you're having it, for the tripwire, all sorts of things like that. Basically how the tripwire works is, the laser will go at one end of the door, like this, shining a light, and the photoresistor will go at the other end of the door, and it will be so that the laser goes over the photoresistor, like that. And when that's broken, when someone walks over, like that, the photoresistor will be able to tell and set off an alarm. And what the code will say is something like, when brightness is over 900, which will be when the laser is on, trigger the alarm, set off the LED. And when it's not over 900, so the laser won't be on, no, sorry, the other way around. When the laser's on, don't do anything. When it's under 900, when the laser isn't on, set off the alarm and trigger the LED. Right, let's just take a closer look at the wiring. I'm just going to show you now in a bit more detail how it works. Here I've got the laser, and here I've got the photoresistor. When I put the laser on photoresistor, the alarm goes off. Okay, now when the tripwire is broken, sorry about this, I can't hold it very still. When the tripwire is broken, it sets off the alarm. Because when there's something going in between the laser and this, it's obviously going to not have a laser beaming onto the photocell. Okay, let's take a closer look at the wiring. To save that buzzer going off, I'm just going to put it to the one next to it for now. First of all, let's have a look at how I've wired the laser. Where is it? Here it is. To make it long enough to span my room, what I've done is, well, not my whole room, but my door, I have used multiple jumper wires attached to each other. But basically, it just goes on the breadboard to 5 volt and ground. And on the laser it goes to either side, 5 volt and ground, like that. So the laser is just permanently on, so you don't need to worry about anything else with that. Photoresistor, this is slightly more complicated, but not too complicated. Here I've got 5 volts going to the pin on the right here. I've got ground going to this resistor, and this resistor is taking it to the left pin. And then I've got a wire here on the left pin going to analog in A0. That's the wiring for that. Then for the LED, I'll just cover my hand on that because you can't, in fact, right. I've got a wire going from the LED to digital pin 11, I've got a resistor going from ground to the cathode of the LED. Bear in mind the LED has two legs, the anode and the cathode. Anode always goes to digital pin or 5 volts, cathode always goes to ground. Then on the buzzer, I've got a wire going from the positive end of the buzzer to digital pin 12 next to the LED, which was 11, and then for the ground side of it, I've got that going to, where did I put it? Here on the breadboard. Bit of a random place, you might say, but this side of the breadboard is powered, this side isn't. And then just a 220 ohm resistor from ground going to a wire here, which takes it to the buzzer. Okay, that's all the wiring you'll need for this project. Now let's go and have a look how photoresistors work and at the code on the computer.
Now, according to Google, which is what I used to look this up, a photoresistor or light-dependent resistor or LDR or photocell, they're all different names for it, is a light-controlled variable resistor. The resistance of a photoresistor decreases with increasing instant light sensitivity. In other words, it exhibits photoconductivity. Now, what this means is, when there's more light, the resistance of it decreases. So it's like a resistor, except from it changes its levels of resistance depending on the amount of light that it receives. If it receives a low amount of light, the resistance will be higher than when it receives a high amount of light. So when the laser is shining on it, when the tripwire is not triggered, it will give off low resistance because there's a laser shining on it. You can't really get much brighter than that. But if the laser's not shining on it and it's just a normal room light or natural light coming in, it's going to be a higher resistance than when the laser's shining on it. That's just very, very briefly explaining a little bit about how photoresistors work, so that you're not using photoresistors and stuff and not having a clue about them. Now let's have a look at the code for this project, and I'll show you once more the project in action, maybe with the laser at one end of my monitor and the photoresistor at the other end or something, because I want you to see it actually working rather than me just holding the laser module above the thing. I did set it up at my door, but I can't remember to set that up again because it takes ages to get it exactly right. Alright, then let's take a look at the code. First few lines are setting up variables, one for the light pin, which is 0, A0, that's what it's connected to, one for the LED pin, which is 11, one for the buzzer pin, which is 12, and one for light reading, which is 0. Now if you wanted to, you could actually set these as constants. Constants are like variables, but they don't change. So the first three you could set as constants because they're declaring pins, they're not going to change, but the fourth one you can't because it will change depending on the resistance given off by the photoresistor. Okay, now let's have a look in the void setup. First line is just starting with serial monitor at the standard rate of communication 9600, and we're setting the LED pin as an output. Then in the void loop, this one's over and over again. So now this actually isn't very efficient, so I'm going to change it up a little bit so that serial.println is below light reading. Just give me 1 second. And then change serial.println to light reading because we've made a variable for it, so there we go. Okay, first line, we're storing the value of what the amount of resistance the photoresistor is giving off in the variable light reading, because it's going to read the light pin, which is 0, which is the pin that the photoresistor is connected to. We're displaying that in the serial monitor, we're delaying it by 10th of a second, then, not 10th of a second, like 100th of a second. If the light reading is above 900, above or equal to 900, this means that the laser is on it. But I've done some experiments with it, and I've decided that when my laser's pointing at it, it's above 9,000. But you might need to change that depending on the amount of resistance you're using, the different laser you're using, something like that. If that's the case, you need to set the LED pin as low and make sure there's no tone going in the buzzer pin. Else, this means that the laser is not on because it's not above 9,000 or equal to. Set the LED pin as high and trigger the buzzer. Now with tone, you've got three things. Before the first comma, you've got the pin. After the first comma, you've got the frequency, and after the second comma, you have got the duration. But because I want this to run indefinitely, then that's what.
One more time. Okay, that'll do. Right. I'm sorry that I couldn't demonstrate it brilliantly well, but hopefully you can see from that how it works. Thanks, Louis. That's all for today. Thanks for watching, and see you next time.